Hello, and thank you for joining this session. My name is Phil Gibson, a program manager here at Microsoft, and today we're going to be talking about Open Service Mesh, a lightweight and extensible cloud-native service mesh that is built on the following core principles of being simple to understand and contribute to, effortless to install, maintain, and operate, painless to troubleshoot, and finally, easy to configure via the SMI specification. In this session, we're going to showcase some demos with techniques you can use with OSM to strengthen the security posture of workloads running in Kubernetes, such as MTLS validation, traffic access policies, OPA authorization policies, and egress access policies. With MTLS, one question we always get is, hey, how do I know the service mesh is providing MTLS? And it's a fair question. So let's set up a simple package capture so that we can see what HTTP data is viewable before and after OSM is installed. Let's first take a look at our pods, and you'll see that we have the bookstore application running and OSM is deployed using the AKS add-on. We'll get the pod name of all the bookstore app services, and next we'll query to get the pod's IPs of all those services and output them. Using the ksniff project, we'll deploy a privileged pod to start sniffing the HTTP traffic on the bookstore TCP port. You'll notice the GET traffic is originating from the actual IP of the book buyer and is destined to the bookstore. Next, we'll onboard the bookstore applications to OSM and restart the deployments for the Envoy sidecar injection. We'll then requery to get both the new pod names and IP addresses. Just to double check, we'll take a look at the book buyer pod and see it has a ready state of 2 of 2 with the inclusion of the Envoy sidecar. We'll now restart the capture. And what you'll notice is the GET traffic is no longer originating from the actual pod IP, but the loopback addresses within the pod. Next, let's look at traffic access. We'll take a look at our pods again, and we're still working with the bookstore application deployed. We'll list out the namespaces managed by OSM and check for the Envoy sidecar in the pod. Next, we'll take a look at the current permissive mode policy setting and that it is enabled. We'll then check the logs of the book buyer and see if it's able to reach the bookstore and it is successfully communicating through Envoy. We'll turn permissive mode off or to false and recheck the logs of the book buyer and see if it can no longer communicate to the bookstore. We'll now deploy a specific traffic access policy allowing the book buyer to communicate to the bookstore. Next, we'll deploy the book thief service that is attempting to contact the bookstore. Looking at the book thief logs, it cannot contact the bookstore without an explicit access policy. We'll update the existing policy to allow the book thief to communicate to the bookstore. And now the book thief can successfully communicate to the bookstore. Next, let's talk about using an external authorization provider, such as using the Open Policy Agent project. Checking the logs, the book buyer is still able to contact the bookstore. We'll now set up and deploy the Open Policy Agent to integrate with OSM. We'll need to edit the OSM mesh config with the OPA endpoint and configuration by adding some necessary attributes. If we check the book buyer logs, we'll see OPA is denying communication to the bookstore even though OSM has a traffic access policy. If we look at the OPA logs, you'll see we have a process rule decision ID with the result set to false, prohibiting the traffic access. We'll now disable the OPA policy rule and restart the OPA pod to take effect. Looking at both the book buyer logs and OPA logs, we can now see successful communication with the rule result being true. Finally, let's talk about the use of egress policies in OSM. If we take a look at the global egress policy, it's set to true, allowing all pods to communicate outside the cluster. We could test this out deploying a curl client to access the http bin.org endpoint. We'll exec into the curl pod to issue the curl command and see we're successful in accessing the external endpoint. Next, we'll disable the global egress policy and see if the curl client can still access the external endpoint. The curl client can no longer access any endpoint outside the cluster. We'll now configure a fine-grained egress policy to allow specifically the curl client to access the external endpoint, but no other pods will have external access outside the cluster. If we check the curl client again, you'll see it has explicitly been allowed to access the external endpoint. We'll now delete the fine-grained egress rule to prohibit external cluster access. Again, thank you for your time, and we really hope you enjoyed this session. Hopefully you saw some new OSM features and techniques that you can go and configure to make your cluster even more secure. If you haven't done so already, please visit the openservicemesh.io page for the latest news and documentation around OSM, as well as visiting the Azure Kubernetes service documentation for setting up the AKS OSM add-on.